Lecture 16 covers sections 5.2 through 5.4. At the end of today's lecture, you should be able to construct Norton and Thevenin equivalents using our standard node voltage or mesh current analysis, superposition, and source transformations, including dependent sources. Thevenin's theorem states that any part of a circuit can be represented as a Thevenin equivalent. For example, consider circuit A connected to circuit B at terminals A and B. We can replace A via a Thevenin equivalent, where we have an open circuit voltage source and a Thevenin resistance. If our circuit has a dependent source, the dependency must also occur in circuit A. That is, when we construct our Thevenin equivalent, we have to take into account the dependent source. That doesn't mean we actually include the dependent source. Rather, VOC and our Thevenin are based upon the dependent source within our circuit. Likewise, any part of a circuit can be represented as a Norton equivalent. Once again, we have circuit A connected to circuit B at terminals A and B, and we can represent circuit A as a short circuit current source in parallel with the Thevenin resistance. Once again, if circuit A has a dependent source, our dependency must be taken into account when we construct our Norton equivalent.